Afternoon. Thank you everyone for joining. My name is Jim Hall. I'm with Stellar Services, but more importantly, today I'm part of the Stellar Waypoint team. So some introductions. The three presenters today are from three different firms. We work very closely together. I'm with Stellar Services. We're an IT services firm. We're nationwide in operation with most of our people and resources though in the Northeast. Imar, do you want to introduce yourself and say a few words?
I'm Imar Busjes, CEO and founder of Moonshadow Mobile.
Great, thanks Imar. And Danielle.
Hi, I'm Danielle Hartman. I'm with Arup, and I'm the geospatial lead for Americas East.
So quickly, then we'll transition into a view of our data offerings. Imar, do you want to take over?
Sure. So my name is, as I said before, my name is Imar Busjes. I'm a CEO and founder of Moonshadow Mobile. At Moonshadow, we specialize in working with very large data sets. We often work with projects that include 10, 50, 100 billion waypoints. So quick introduction for those who are fairly new to this technology. What are waypoints? Vehicles and mobile devices generate information as they are moving. And so they can send an update of their location as well as speed, heading, and other aspects into the cloud every few minutes or even as frequently as every few seconds. And so what we can do is we can combine all the points from a single object into a trip. And then of course, we can go on and take the information from thousands or in often cases millions of trips to generate information about the use of the road network or the mobility patterns in an entire region. Then we have a number of data handling products, and I'll go through those in order. MMZip, first of all, is a technology developed by Moonshadow that reduces the size of the data by 90%. The problem with this data is that it is so large. You're often talking about terabytes of data. And so by reducing it to less than 10% of its original size, you speed up data transfers 10 times, you reduce transfer and storage costs by 90%. But where MMZip really shines is in its ability to merge waypoint data and combine it with other sources of data during the decompression at very high speeds. So for instance, and this is essential for the product offerings that we're showing today, MMZip can take in billions of waypoints, take in the road network information from a DOT GIS system or from OpenStreetMaps or another map provider, and combine this and assign waypoints to road segments at a speed of more than 1 million assignments per second per server. And that's really an essential enabling technology. Once MMZip has enriched the data, it goes into DB for IoT. This is a Moonshadow technology that was developed specifically to store, process, and enrich and interact with billions of records from either connected vehicles or mobile devices. What's very interesting about DB for IoT is that it has an application programming interface, an API, that is very complete. And the API is what enabled Stellar and Arup to create the Waypoint GIS connector together with us. Because what they can do using the APIs is they can pull information at aggregate levels from the DB for IoT repositories, assemble that and create dashboards that are customer specific for the DOTs and the agencies that work with them. So here's an example of what MMZip does. On the left side, you see WeGeo data for Phoenix, Arizona. These are waypoints. This is point data. On the right-hand side, you see how MMZip has snapped this waypoint data to the road network from the DOT's GIS system. Then now we're getting to the meat of the presentation today, the GIS connector. So as I've been explaining, the top, it all starts off with the waypoints and the GIS road lines. Those two data elements go into MMZip. MMZip combines them, and MMZip can assign waypoints to multiple map layers at the same time. Once the data is enriched, it goes into DB4IoT. From there, the data is, and using the DB4IoT APIs, the data is combined into a geodatabase, and from there it can be displayed as a regular geodata in a GIS system such as ArcGIS. So our technology is in principle data agnostic. So we can work with any source of waypoint data. And as I've talked about before, in our offerings through the ETC traffic data marketplace, we work with Michelin, Autonomo, Cambridge Systematics, and the driver's seat. But we can also work with the other major suppliers in the ETC. The reason I'm mentioning the ETC here is that as a vendor of the ETC, the data can be procured without the necessity to engage in a full RFP project process through the traffic data marketplace from the Eastern Transportation Coalition. Of course, we also work outside of the 17-state ETC region, and there you can procure the GIS connector directly from any of the three of us, Moonshadow, Stellar, or Arab. So we also work with INRIX. INRIX is a major provider of data as well, and with Wegeo. INRIX collects data from OEMs, but also through their own mobile apps. Wegeo has arrangements with OEMs, and they currently have the largest OEM data repository in the US. They cover probably over 13 million vehicles. So that's the introduction of our technology, and now I'd like to hand it over to Danielle Hartman, who is the East GIS lead for Arab, and she'll talk to you about some of the use cases of how this data can be used. Go ahead, take it away, Danielle.
Thanks, Aymar. So as we've been talking about, these waypoint data sets are really, really large. And for a single city, depending on the time period, you can be talking about trillions of records. And it's so time consuming to create the derivative data sets with standard desktop software packages. Oftentimes, we just don't use this data as often as we would like to because of the technical overhead of processing these large files. So our GIS connector is intended to break through those bottlenecks and streamline the workflow as much as possible, do all the technological heavy lifting on the server side using all of these really awesome data processing tools that Moonshadow has developed. So I'm going to focus on the right-hand side of this workflow. Once you start working with your GIS systems, the data has already been procured from a vendor. The MMZip has already processed this data, the waypoints into street center lines. You'll choose a time interval to do your aggregation and develop this really nice compact geodatabase attribute table, which will work with the GIS base map that your agency prefers, whether you've developed it yourself, if you're the state DOT, or if you prefer to use the OpenStreetMap or something else, the technology will work all the same. So once all of that data is processed, it goes into your ArcGIS enterprise data system that can be hosted by Stellar or by Arab if you don't have your own server already, but of course we can customize that as much as needed. So the intention of the GIS connector is to get all of the power of these big data sets to your traffic planners and your traffic engineers and start developing really interesting use cases with this rich ecosystem of data that is now available to us. And again, we try to make it as easy as possible so your IT department doesn't have to get involved in procuring extra servers and doing all of that database management on your behalf. So I'm going to talk about some use cases that we developed for New York City as we were exploring the idea of vehicle traffic speeds. So we'll show you 4 different use cases looking at vehicle speeds in New York City. So here's one of the source data sets. New York City Michelin data, there's almost 1 trillion records. We compressed that all down into a very manageable geodatabase and produced this web map animation file in a couple easy steps. So this example, we're looking at what happens in terms of congestion on the local road network before and after a Mets game at Citi Field. So here we're seeing speed, average vehicle speed compared to the posted speed limit for each street segment. And the red areas are places where there is a lot of congestion. The next case study, we're looking at a very simple map, just looking at the bridges that cross between Manhattan and Brooklyn. And so we made a series of charts showing peak times for traffic at these 4 major crossings. The third case study is looking at the entire borough of Brooklyn. So this was a bit of a larger data set, and we were looking at speeding hotspots across the borough. So those are shown here in blue line segments, the places where there was the most speeding recorded. And then we combine this with data from the New York City Open Data Portal of where speeding tickets are most frequently given. And so that shows patterns where there are more and less speeding incidents getting ticketed. So we have one more case study we'll show really quickly. And this is a data dashboard that our traffic planners helped us design, looking at a safety study in a specific neighborhood. So we went through the Waypoint data and pulled out statistics of where is speeding happening in this neighborhood, what are the conditions of those speeding, what street segments, how much is speeding happening, how frequently, and there's an interactive dashboard where they can explore the statistics that they typically use in their planning studies. So my last slide is just to talk a little bit about the numbers of the different file sizes. So the first graphic with the green dots all over New York City, that was 2 weeks worth of Michelin Waypoint data, and we only had almost a trillion data points. If you look at the street base map for New York City, there's about 117,000 street segments. So the MMZip software takes that trillion record Waypoint data set and compresses it in time and space and gives you some multiple of 117,000 depending on the time period. So the resulting database size for the first animation showing the Mets game, we had a database with less than 20,000 records, which runs really easily as an animation in a web map, as you saw.